For the first 5 months of 2026, California's electric grid got more power from solar than from natural gas. Not for a day, not for a week. For 5 straight months, January through May, solar generation outpaced natural gas as California's single largest electricity source. Solar generation climbed 21% compared to the same period last year. Natural gas generation for power dropped 60%. The energy transition everyone has been debating for a decade just showed up in the data. CAISO, the California Independent System Operator, manages the high-voltage grid for roughly 80% of California, approximately 40 million people. It is one of the most heavily studied grids in the world because California has been at the front edge of renewable energy integration longer than any other large U.S. system. What just happened in CAISO is worth understanding, not just as a California story, but because every major grid in the country is following the same trajectory at some distance behind. First, what drove the shift? California has been adding solar at an aggressive pace. Utility-scale plants in the Mojave and San Joaquin Valley, but also rooftop solar, panels on houses, warehouses, and commercial buildings, at a scale no other state matches. The economics made it inevitable. Utility-scale solar is now the cheapest new generation you can build in most of the country. At near zero marginal cost, solar displaces anything with a fuel bill. Natural gas plants still exist on the system, but when solar is producing at zero marginal cost, gas plants cannot compete on price during those hours. They run less. Over 5 months, the cumulative difference became a milestone. But solar beat gas is a headline that needs translation. When we say solar generated more than gas over the 5-month period, we are talking about the total across all hours added up. Sum every kilowatt hour from every solar panel from January through May, and it exceeds the total from every gas plant over the same window. That is significant, but it does not tell you what the grid looks like in any given hour. An hour to hour is where the operational engineering lives. Here is the shape of a typical solar day on the California grid. At midnight, solar output is 0. By 7 a.m., panels begin generating as the sun rises. Output climbs through the morning. Around noon, peak solar hits. On a clear spring day, that is 15,000 to 25,000 megawatts flooding onto the grid simultaneously. Then the sun starts dropping. By 6 p.m., solar output is falling fast. By 9 p.m., it is essentially 0. This is a 24-hour cycle that repeats every day. And the shape of it, the midday mountain, the evening cliff, creates a specific set of challenges that did not exist when gas and coal ran the grid around the clock. Grid operators call this the duck curve. The name comes from what you see when you overlay solar generation against total electricity demand on the same chart. The low point in the middle of the day, where solar is generating so much that net demand after solar drops toward 0, looks like the belly of a duck. The steep rise in the evening, when solar drops and human demand is still high, looks like the neck. The belly creates an oversupply problem. The grid is generating more power than it can use. Either you curtail the solar, just throw it away, or you find somewhere to put it. The neck is the harder problem. In roughly 90 minutes, the California grid needs to replace thousands of megawatts of solar output with other generation. That ramp has to happen fast, reliably, every single evening. What fills the neck? 3 things, in this order: batteries, natural gas peakers, and electricity imports from neighboring states. California has been building battery storage faster than anywhere else in the country. By mid-2026, the state has over 10,000 megawatts of grid-scale battery storage online, systems that charge during the solar peak and discharge into the evening ramp. It works. Batteries have materially reduced California's reliance on gas during the 6 to 8 p.m. window. The evening ramp that used to stress the system is now largely absorbed by batteries that spent the afternoon filling up on excess solar. But batteries have limits. Most discharge for 2 to 4 hours, depending on the system design. By 10 or 11 p.m., When demand is still running and solar is gone and batteries are depleted, something else has to cover the load. That something else is still natural gas. This is what gas actually does on California's grid in 2026. Not baseload, not running around the clock. Gas runs two windows: early morning, before solar can carry the load, and late evening, after batteries have discharged. That is a different job than what these plants were built for. A combined cycle gas plant was designed to run continuously. Startup is expensive. Thermal cycling wears down equipment. Now they are being asked to sit idle for 10 hours, ramp hard for 3 or 4 hours, then back down. The plants that can handle this operating mode are running. The ones that cannot are retiring. The mix of gas remaining on the California system is increasingly a peaking resource, not a baseload workhorse. If you caught the previous video on what gas plants actually do for the grid, you know that generation is not only about supplying energy. Spinning turbines provide inertia, the physical resistance to sudden frequency changes when something goes wrong on the system. They provide fault current, the surge of electricity that tells protection systems where the problem is and trips the right breakers. Solar inverters do not provide either of these things inherently. As California's gas fleet shrinks to a peaking role, the system's total inertia comes down. The fault current available during a disturbance gets smaller. These are manageable engineering problems. They are not self-solving ones. CAISO has been ahead of most grids in addressing this. Grid-forming inverter specifications, requirements that tell batteries and solar inverters to behave more like synchronous machines during frequency events, are part of California's interconnection standards. FERC Order 901, issued in October 2023, extended similar requirements across the whole country. Inverter-based resources must demonstrate ride-through capability. Model validation is required. Planning standards must account for actual inverter behavior. California is further along the implementation curve than most of the country. But ahead does not mean done. The full FERC Order 901 compliance timeline runs to January 2030. The 5-month data from CAISO is not just a California story. Texas is on the same trajectory. ERCOT's solar penetration has been growing faster than most markets anticipated. The Southeast is starting to see material solar contributions. The Midwest is 5 to 10 years behind California's current state. Every large grid in the country will eventually face the same operational reality that California is navigating today. A system designed for dispatchable, fuel-burning generators trying to absorb a resource that follows the sun, not the load. The question is not whether the transition happens. The EIA data says it already is, at least in one of the largest and most sophisticated grids in the world. The question is whether the supporting infrastructure gets built fast enough to stay ahead of what the transition creates. The batteries, the grid-forming inverters, the updated protection settings, the new planning standards. California generates more solar than gas for the first time in history. The FERC Order 901 planning standard deadline is November 2026. Full compliance runs to January 2030. The grid physics do not wait for the rulemaking to finish.